Assalamualaikum students. Students, in this lecture, we are going to do the Born-Haber cycle to calculate the delta H lattice. Right? Now, Born-Haber cycle is kind of Hess law. Like the main point of the Born-Haber cycle is that enthalpy change of a reaction does not depend on the root of the reaction. If initial and final conditions are same. Like if a reaction can be done in 2 or 3 steps, and or in 2 or 3 routes, you can say. At the end, if the start and the stop is the same, the enthalpy change would be same, right? You have to keep the condition also same. That is the main point of the Hess law. That if the initial and the final condition and everything are same, then enthalpy changes would be same. Now, to explain Born-Haber cycle, to calculate the delta H lattice, I'm going to share the screen with you people, but when I'm sharing the screen, you guys are supposed to like, subscribe and share my channel, okay? ये तो बेटा आपको करना होगा ना, तकरीबन मैं आई थिंक रोज ही आप लोगों को ये बोलती हूँ कि आपको ये 3, 2, 1. Okay, so we are doing the delta H. In between, I paused actually the recording. So I think you will find that I'm starting it again, but it was due to pausing. So we want to find out delta H lattice of magnesium nitride. In this question, they have given us the magnesium atomization. Like this question is from a bit like you can see that it's from the papers before 2022. So you need to use data booklet in that question. So atomization of magnesium is given. The conversion of N into N3 minus is given. The enthalpy change of formation is given. So you're supposed to find out delta H lattice. Like if I use the same information and do it on that page for you people. Look at this. Yes. Now, how you are supposed to do? Again, small arrow down, and this is what? Long arrow, and you are supposed to do what? Magnesium nitride. Magnesium nitride is Mg3 N2. Magnesium nitride. Its formation and its delta H lattice that you want to find out. And the formation is how much, which is given to you in the question? Minus 461. And the formation of magnesium nitride is from what? It is from 3 magnesium solid and nitrogen. And the delta H lattice is from what? It is from 3 magnesium ion and 2 nitride ion. Right? Now what you are supposed to do? For metal, it is always the same. Atomize. But you are atomizing 1 magnesium or 3? 3. So 3 times the atomization, which is how much? 148. And then 3 times first and second ionization energy, which is 736 and 1450. Now, what you are supposed to do? This is nitrogen. No atomization is given, nothing, but it is gas. Can we use bond energy directly? Yes, using data booklet. The triple bond will break. The bond energy will turn this into 2 atoms. Of course. So you need to break this into atoms, and then I will use bond energy data booklet to get the bond energy from this. Wait a minute. Now, and I will show you even these 2 values that this I have taken from the ionization data booklet. Now, what is happening here? 2 nitrogen into 2. Like actually it's N into N3 minus 2 times. So 2 into what? 2148. 2148. So if I use data booklet, what I'm supposed to do? Data booklet. See, Born-Haber cycle, I have to explain. You know what is Born-Haber cycle? Haber cycle. Used to primarily to calculate delta H lattice, right? Now, for delta H lattice to calculate using Born-Haber cycle, like it can be used to calculate electron affinity, ionization energy, formation, anything which is unknown and the rest are known, you can calculate. But like direct Born-Haber cycle is linked to delta H lattice, right? Now, what you are supposed to do? Draw two arrows. One small, this is I think the easiest way to do. Two arrows, both downward. This is 1 mole ionic lattice. This is formation and this is delta H lattice. So, formation formation is always from its element and lattice is from its gaseous ions. Look, the formation of ionic lattice from its element, which is most of the time metal and non-metal. Metal and non-metal. The metal is always solid, but the non-metal could be solid, could be liquid, could be gas. Right? Now, delta H lattice, it is from what? 1 mole of ionic lattice from its gaseous ions, from cation and anion. Now what you are supposed to do? This is formation, this is lattice, it is from element, it is from ions. Now you are supposed to link the metal to cation, the non-metal to anion. How can you link a metal to cation? You have to atomize the metal, you have to break the metallic bond, you have to turn the metal into atoms. Once it turns into atom, it's going to lose electron, ionization energy. Huh? You need to break the metal into atom, and then the atom into cation. So what is the first step? Delta H what? Atomization. Delta H, atomization of the metal. And then ionization energy of the metal to lose electron. Now what is happening to the other side? It is turning into atom, the atom lose electron, it is turning into atoms. They are gaining these electron to make anion, electron affinity. It's a redox reaction. The metal first turn into atom, then they lose electron. The non-metal turn into atom, then they gain the same electron to become an ion. Now, to convert the non-metal into atom, there are two possibilities. You can directly turn the non-metal into atom. This is what delta H atomization. Or first you have to convert the non-metal into into molecule, gas, and then the molecule turn into atom. Look, directly non-metal into atom, or the non-metal first vaporized, sublime, if liquid, then vaporize, if solid, then sublime. But if it is gas, it remains the same. And when it becomes the gaseous molecule, then you can use bond energy. You know what is bond energy? It's the amount of energy needed to break covalent bonds, one mole covalent bonds in gaseous substance. You can't use bond energy directly. You have to convert the non-metal first into gaseous and then the bond energy. So there are two possibilities: either non-metal direct atom or non-metal first turn into gaseous and then break the covalent bond atom, and then the atom will gain electron affinity. Look what happens in Born-Haber cycle. The metal atomize, then lose electron. The non-metal, either in that question there would be atomization, which is very less likely to occur. Most of the time, they are in the new papers. There are atomization, but in the new papers they are using these vaporization, sublimation, and bond energy concepts more, right? Because like this is the only place where I've seen the students they struggle. Right? So if you already know that for solid and liquid, I have to vaporize and then I will use bond energy and then I will get the atoms and the atom gain electron. So become an ion. So if you look at this structure clearly, you are actually having this situation. From metal and non-metal, you can get ionic lattice, direct formation, or this way. It's not taking prediction. It should take. Yeah. Or this way. Look, either direct or this way. So, don't you think that the enthalpy change of the formation is equal to the sum of all these? The formation is the sum of all these. Now, see, if I apply the same on zinc bromide, at the same time, I want to show you the note so that, look at this. This I have done. Born-Haber cycle to calculate what? Delta H lattice. Delta H lattice. This is Born-Haber cycle. This is your formation. This is what? Delta H lattice. This is formation. This is delta H lattice of 1 mole of ionic lattice, right? The metal atomizes, then it loses electron. The non-metal can turn into the same atom, either by direct atomization or if it is solid, then you have to sublime this into molecule. If it is liquid, then you have to vaporize. And then, but if it is gas, then direct bond energy to make the atoms. Like for non-metal, you have to be very careful that are you dealing with solid, liquid, or gas. You can use bond energy for gases directly, but you can't use bond energy for solids and liquid. You have to first convert them into molecule. But yes, atomization is for metal and non-metal direct way to get atom from the element. And then the atom gain electron, making anion. The metal atom lose, the non-metal atom gain. Then the ions are making a lattice. So it's exactly this way from start and to the stop. There are two routes you can see. Their enthalpy changes same. Now I am going to use zinc bromide as an example. Okay, so in zinc bromide, look. If you see, two arrows, one arrow down, small, and one long arrow down. Oh, the smaller one is what? The smaller one is formation. The smaller one is formation of zinc bromide solid. From zinc solid and bromine at standard condition is liquid, and this is delta H lattice, making 1 mole of zinc bromide from zinc gaseous ions and 2 bromides. Now, what you are supposed to do? You need to convert zinc into zinc atoms. And you need to convert the bromine into bromine atoms, 2 bromine atoms. Listen, now there are 2 ways. When you atomize zinc, it's just delta H atomization. You make the zinc atom from its element. Perfect. It's 1 mole atom, so 1 atomization kilojoule per mole of the zinc atom. Now, when you are coming at bromine liquid, the bromine liquid has covalent plus ID, ID. ID, ID, because it's a these are same atoms, no electronegativity. The difference is, so it is ID, ID. Now, if I go for the direct conversion of 2 mole of bromine atom, 2 mole of bromine atom from its element, so it's what? 2 atomization. 2 atomization or first vaporize bromine, liquid into gas, enthalpy change of vaporization. And now you will break the covalent bond, the bond energy. Like when you break the covalent bond in the gaseous bromine, 1 bond energy making 2 bromine atoms. What is the next step? The zinc will lose electron, first plus second ionization energy. Like first zinc will turn into Zn1 plus and then into Zn2 plus. 1 mole of zinc, right? But on the other side, the 2 electrons lost by the zinc are gained by 2 bromine, 1 by each bromine. So 1 bromine gain 1 electron. Another bromine gain another electron. The same process twice. So 2 times first electron affinity. So what we can say? Can we say that this formation is this equal to the sum of all these? I want to do it this way. Yeah. So can we say that this formation is equal to sum of all these? Of course. So whatever is unknown, you can find, but for that, the rest must be known. So can we say that enthalpy change of formation of zinc bromide solid is equal to atomization of zinc first plus second ionization energy of zinc plus 2 atomization, which is equal to, like you have to this or what? Vaporization plus bond energy plus 2 times wait, let me show you, plus 2 times delta H electron affinity plus what? Delta H lattice, right? So whatever is like this is for zinc, I have to write it. It is for zinc. For zinc, this is for the bromine. This is for bromine. This is for ZnPr2. So whatever is unknown, like suppose this is unknown, take the sum. If this one is unknown, this is 2x. The rest are added and subtracted from this. You'll get your answer. Can we apply? Can we apply exactly the same? Can we do it for magnesium? Magnesium, like look, I want to share this with you. Wait a minute. This is a question solved for you people, right? Now, look, I am doing it for this magnesium nitride. See, there is a question. This question of zinc bromide is given here. In the notes, you will find my notes on my website. So go there and take the notes. Right now, focus on the methodology so that you can understand. Look, we want to find out what? Magnesium nitride. Delta H lattice of what? Magnesium nitride, right? For nitrogen, it is 944. And for magnesium, 736 and 1450. See, 736 and 1450. So, if I go to that question again, what am I supposed to put here? 944. So, this is the sum of all these? Yes. So, how am I supposed to write? Minus 461 is equal to 3 into 3 times 148 plus 3 times 736, 1450 plus 944 plus 2 times 2148 plus x. Add all these, bring this to the other side and get your x. Easy peasy. Next, listen. If in your molecule there are molecular ion in the lattice, for example, potassium sulfate, magnesium nitrate, ammonium chloride. Now, is this molecular ion, molecular ion, molecular ion? Yes. How you will deal these? For molecular ion, the Hess cycle would be like this. Listen. Like you must know this. It's easier than the previous, but one thing is clear. If you don't know how to do it, it's like quite difficult to do this on the spot, right? So for molecular ion, again, two arrows, one small and one big arrow. One is as usual. Can you suggest what? The smaller one and the bigger one, what are they? Think. The smaller one is formation and the bigger one is lattice. And suppose I am doing this for potassium sulfate salt. Formation, it is from 2 potassium metal, 1 sulfur and 2 O2. Formation of potassium sulfate, and lattice to potassium ion and 1 sulfate ion, right? And for the metal, the same atomization. And then this is atomization. How many times? 2. Why? Because there are 2 potassium atoms that are made from the elemental state. And now 2 into what? First, ionization energy. Okay. What about this? Their bond will break, and they are going to make new bonds, and then they are going to gain electron. Like a lot of thing inside this. Their bond will break, they are going to make new bonds, and they are going to gain electron. This whole process, this you are not supposed to do. In this case, direct either formation of sulfate. Formation of sulfate would be either given or this would be unknown. Like for molecular ion, keep in mind, they're not going to ask you. They do the steps because this is again internally a full a full Hess-law kind of situation. A full cycle is involved. Like, मुसलसल गलतियां कर रही हूँ बोलने में, I don't know क्यों. Full cycle है इधर. Like there is a whole situation. Bond breaking, bond making, electron acceptance, which is not easy to be handled by the student. Therefore, you will be either asked or given in the molecular ion this step. Right? See, these are your past papers. Question. Look at this. This I have done for the iodine. This is a question. Look, this I have explained for potassium sulfate, the same thing in the notes, right? But this is a question from the past paper. Look, what you are supposed to find? Formation of the hydroxide, formation, but the information is of magnesium hydroxide. Like you have the formation, you have the lattice, see? You have the formation, you have the lattice, atomize, ionize, and this step is directly asked. Look at the others. Oh, it's not given. In my topical, the question number 6 have 3 parts from 3 different papers. In one, the question is about sodium azide molecular ion. Azide is 3 nitrogen with -1 charge. This is azide, this is not nitrite. Right? Now, the second question is about magnesium hydroxide and then barium sulfate. All these are in your past papers in the recent years. So you guys must know that how to find out, how to construct Born-Haber cycle and to find delta H for molecular ion as well as the other simple binary ionic compounds. I think this is sufficient. Now you are supposed to do the practice of Born-Haber cycle. Use the topical which are given on my website. You will find them very helpful. Inshallah. And the notes are also given. Allah Hafiz, and don't forget to like, share, and subscribe everything. Okay, bye.